Hello, I am Sahajpreet Singh and I am thrilled to present Bat vs. Rat, the forage file for Foundation of Data Science, joined by Tejpal Singh, Yuvraj Singh, and Kashdeep Singh. We investigated how bats take risk when foraging around rats. Our study explored how time, season, and food rewards influence their behavior. Let's dive into the introduction to understand the context of our research. Bats often share habitats with rats, competing for food resources. They face a choice, risk conflict with rats, or avoid them at feeding sites. We study how bats balance these risks and rewards, focusing on factors like time since rat arrival, hours after sunset, and seasonal differences. This research helps us understand ecological competition and how animals make survival decisions in challenging environments. Our study had three main objectives. First, we aimed to confirm it bats take risk when rats are present. Second, we explored how risk taking relates to the likelihood of obtaining food rewards. Third, we examined whether time after sunset or seasonal changes influence bat behavior. These goals shaped our analysis to uncover what drives bad decision making in competitive. We collected data on bat foraging behavior, tracking their landings, rat arrivals, and whether they secured food rewards. Key variables included risk taking, categorized as avoid 0 or risk take 1, reward success, seconds after rat arrival, hours after sunset, and seasonal variation. These variables allowed us to analyze how bats make choices under specific environmental conditions. Tejpal will now share our results.
Slide 5 results Chi-square test. Hi, I'm Tejpal Singh. Our chi-square test shown in the figure 1 gave a statistic of 435.99 with a p-value less than 0.001 indicating a strong link between risk-taking and food rewards. Bats don't act randomly, they are more likely to take risk when food is available. Predicted counts show high risk-taking aligns with rewards, while avoidance is less tied to food acquisition. Slide 6 T-test. The T-test shown in the figure 2 examined the since rat arrival for risk-averse versus risk-taking bats. With a t-value of minus 1.12 and p-value of 0.26, there is no significant difference. Both groups show limited time distributions, peaking early and slowing later, suggesting time for since rat arrival doesn't strongly influence risk-taking behavior. Slide 7 Logistic Regression Model. Our logistic regression model shown in the figure 3 is significant p 0.001 and explains 42% of bad behavior variation. It predicts risk-taking well, but the remaining unexplained variation suggests other unmeasured factors like environmental conditions also influence bad decisions. This highlights the complexity of their behavior. Slide 8 Classification Table. Our classification table model achieved 84% accuracy for avoidance class 0. Recall was high at 0.93, catching most cases, but precision was 0.78, indicating some false positives. For risk taking class 1, precision was 0.92, but recall was 0.76, missing some classes. F1 scores 0.83 and 0.85 show balanced performance. Yuvraj will now present our visualizations.
Hello, I am Yuvraj Singh. Visualization Part 1. Figure 4th bar chart compares risk taking avoidance counts showing bats behavioral tendency. Figure 5th heat map illustrates the strong link between risk and reward, confirming that food availability drive bats to take risk. These visuals make it easier to understand the patterns in our data. Visualization Part 2. Figure 6. Box plot showing time since rat arrival versus risk. Spots that is tested indicated no major difference between groups. Figure 7. Scatter plot of rat arrival versus bat landings highlights interaction pattern, reinforcing that rewards, no timing, drive behavior. These visuals clarify our findings. Summary visuals. Figure 8. Bar plot shows risk taking by season, suggesting some seasonal influence, though less significant than rewards. This visual summarizes how environmental factors like season interact with bad behavior, providing a clear overview of our key findings. Akashdeep will now discuss our results.
Hi, slide 12 discussion. Hi, I am Akaship Singh. Our cheese care and regression analysis confirm rewards strongly drive bad risk taking even with rats present. Time factors like second after rat arrival showed weaker effects. The model's 84 accuracy is strong, but moderate risk taking recall suggests other factors like predator density influence behavior and need further study. Slide 13 Conclusion. In conclusion, food rewards are the primary driver of bad risk taking, outweighing time or seasonal effects. Bats adapt flexible to balance risk and reward. Model limitation suggests exploring factors like species variation. This study combines ecology and modeling to understand animal discussion in dynamic environments. Slide 14 References. Our sources including Gonzalez, Oliveira, Pergams, Riquelme, Rogel Salazar and Sivage, 2024 and 25 provided key insights into bad behavior and data science. Thank you for listening to our presentation. We are ready to answer your question.